Alright, section 8.3. I'm going to go through this pretty quick. 8.2, we said, hey, here's a parallelogram. Why don't you, and then here's some characteristics about it. This section, we say, hey, here's a quadrilateral. Here's a four-sided object. Tell me if it's a parallelogram. Figure out if it's a parallelogram or not. So I'm going to go through these theorems pretty quick because they're kind of the opposite. They're the converse of the 8.2 theorems. So here we go. I want to go through them fairly quick. It says, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So it says this, if BC is congruent to AD, AD, and we should probably label the sides here, right? A, B, C, D. If that's true, and AB is equal to CD, then ABCD is a parallelogram. Let's see, that's parallelogram. ABCD is a parallelogram. Is a parallelogram. Alright, so now we want to do an example here. We're going to find what values of x make the quadrilateral a parallelogram. Once again, we've got A, B, C, and D. Okay? So A, B, C, D. What values make a parallelogram? Well, I know this. I know that in a quadrilateral, consecutive interior angles, if they add up to 180, if they're supplementary, then I've got a parallelogram. So let's check. Once again, I'm looking at consecutive angles. 4x and 38 are consecutive. They're supplementary, which means they add up to 180. So 38 plus 4x equals 180. Okay, so let's solve this for x. I'm going to minus 38, and it's just a two-step equation, right? So when I do that, I get down to 4x equals 142, divided by 4, get down to x equals 35.5. Okay, and that's it for that one. Let's move over to this other example here. And in this one, once again, we're going to use the same idea, and we're going to find x that makes this parallelogram a quadrilateral. Quadrilateral a parallelogram. Okay, I know that consecutive angles add up to 180, so I'm going to find x in this. In fact, this would be a good problem for you to do on your own. So try this one on your own. I know that 2x and 3x plus 5 are supplementary. So using that information, why don't you find x on your own? Okay, in these last examples, once again, I want to show that ABCD is a parallelogram. Okay, so we'll do this first example. A, B, C, and D. I want to show that that's a parallelogram. Okay. Well, I know that if it's a parallelogram, then the diagonals bisect each other. Okay, so the diagonals bisect each other. That means that not only are this diagonal right here, AC, not only does that get bisected, but also these diagonals right here are bisected. Okay, so so for this one, I should get 5x minus 8 is equal to 3x. Alright, and I want to solve this thing for x. I'm going to subtract 5x from over here, subtract 5x from over here, and I get negative 2x equals negative 8. Oops. Sorry about that. Equals negative 8 divided by negative 2. I get down to x equals 4. Okay, so x equals 4 on that one. This next one, you should pause and try for yourself, and I'm going to give you the answer to this one, but I want you to try it, and you're going to have to show your work to get credit for your notes on this one. So, so pause it now, Good. Hopefully you paused it and tried that example. And now I'm going to give you the answer. You should have gotten down to x equals 0.4. So hopefully you tried it and you got down to x equals 0.4. Remember, for credit on your notes, you need to show that work. Show the work. Exclamation point. Okay? And that's it for section 8.3. Now, we're going to do some more examples probably in class, but that's basically, it's very, very similar to 8.2. So good luck on your homework, and we'll see you in class tomorrow. Theorem 8.8. All this one says is that if I have both pairs of opposite angles congruent, then the quadrilateral is a parallelogram. So, once again, if I have A, B, C, D, and opposite angles are congruent, then I know I have a parallelogram. So, real quick, if measure of angle A equals measure of angle C, measure of angle D equals measure of angle B, then ABCD is a parallelogram. Okay, so once you've got that down, let's move on to the next theorem. Theorem 8.9 says that if one pair of opposite sides of a quadrilateral are congruent and parallel, so this one's a little bit different. If one pair is, we've got two things. We've got congruent, we've got congruence, and we've got parallel. If I know those two things, then the quadrilateral has to be a parallelogram. Okay, so if I know that A, B, C, D, if I know this, if BC equals AD, then I also have BC parallel to AD. Right, these are parallel symbols. If I know that, then, you guessed it, that was the cat, BCD, ABCD, that's not an E, that's a C, is a parallelogram. Is a parallelogram. The last one here is if the diagonals of a quadrilateral bisect each other, this is bisect each other, then the quadrilateral is a parallelogram. So once again, I'm probably not even going to write the whole thing out here. If I've got bisecting diagonals, if I know that, then I know I've got a parallelogram. That's it. If I know those things are equal, then I know I've got a parallelogram. So if I and maybe I can draw this in here. Let's try a different color. If I know, that I've got these congruence marks here. So if that stuff is true, congruence, then A, B, C, D is a parallelogram. Okay, so I'm not even going to write that out. So that should be then. Then A, B, C, D is a parallelogram. And ABCD is a parallelogram. Okay, so if congruence of the bisectors, if the diagonals bisect, I've got a parallelogram.